In this segment, we're going to use an online tool called Green Charts to visualize interval data for element 2. Once you have the interval data file for your building in the XML format, you need to upload the data file to the website. Click on Upload Your Data, then find your data file on your computer. If the file is uploaded successfully, you should see the monthly electricity use plotted. The upload might fail if the data file is too large or if the file is in the wrong format. The file should have the XML file format, not the CSV file format. If your file is too large, you may be able to download 1 month or several months of interval data at a time rather than a full year. Once the data is uploaded, you can then click on any individual month to show the electricity usage for each day in that month. From the daily usage, you can answer the question, what is a typical weekly pattern, asked in Step 2 of the interval data worksheet. Here there's a clear weekday-weekend pattern. Let's take a look at how much energy is used on holidays. We see that the New Year's Day holiday fell on a Sunday, so the holiday was observed on January 2nd. And the load here shows the weekend load level, so lower than a typical weekday. But if we look at Martin Luther King Day on January 16th, that day shows the typical weekday level. You can also click on an individual day to show the hourly usage during that day. Try clicking on different days to see how the daily load profile changes from day to day. For example, the weekend load might have a different shape than the weekday load. One thing to be aware of here when you're comparing different days is that the vertical axis limits change when you switch between days, and that the axis doesn't start from 0. Step 3 in element 2 asks about the base load. This is the base amount of power that's being used at all times, so it includes the power for any electronics or other devices that are always running. To find the base load, you want to look for the lowest level typically used during the week. Here we see the lowest level is on the weekend, and we can see that the base load usage is 0.035 kilowatt hours over 1 hour, so the power level is 0.035 kilowatts. A good rule of thumb is that the base load should be no more than half of the typical daily maximum load, and can often be much lower than that depending on the building type. Here the typical daily maximum is about 0.25 kilowatts, so the base load is only about 15% of the maximum load. Next, in Step 4, we want to look for load spikes and unusual activity in the daily load patterns. As we click through, most of the days follow a similar pattern, so this sample building is pretty well behaved, but there are some unusual things we might want to take note of. For example, there is a sharp increase on Sunday evenings at around 10 p.m. when some of the weekday process loads seem to come on, so you might want to find out if this is the intended start time. In Step 5, we come back to the maximum load to ask when this maximum occurs during the day. Some utilities charge higher rates in the afternoon when demand is highest, and as a result, businesses can save money by shifting activities earlier or later in the day. For the building in this example, the peak typically occurs at around 8 a.m. For Step 6, you might want to use the monthly and daily usage plots to look for any gradual or abrupt changes in electricity usage. Here, you can see that between November and December of 2011, the usage went from being very irregular in November to following a regular weekday-weekend pattern in December. This might signal a change in how occupants are using the facility.